Alright, hello again. This is the 2012 paper, the second paper, electric power, question 2, A and B. These are about DC electric motors. So question 2 is asking, it shows a small DC electric motor, it's powered by a battery and there's a split ring commutator. They give you the dimensions of the coil within that, but within the magnets, and there's 50 turns. 50 turns means 50 loops. So there's 50 loops. 50 loops. And they give us the magnetic field strength. So we've been given quite a lot of information, but in the first question we don't actually need to use any of these numbers. The first question is just asking us what's going to happen when the current's switched on. Right, which way is this going to turn? So they give us 4 options to choose from. The first one, the coil is going to rotate in the direction A, that way. The second one, direction B. The third one is going to oscillate back and forth between A and B, and the fourth one says it will remain stationary. Now this is a DC motor with a commutator. Because it has a commutator, it's going to rotate continuously. It only would rotate back and forth, oscillate regularly back and forth, as in question part C, if it was instead of a commutator here, it had slip rings. But it has a commutator, so it goes in one of the directions. So we know it's not that one either. Now which way does it go? We have to use the right hand rule. The right hand slap rule. This is the third of our rules. And if I was to draw my right hand, I'll attempt to draw my right hand. Some fingers here, and thumb, and this is the palm of my hand. The thumb's going to be pointing out to the side there. The fingers are the direction of the field. My thumb goes in the direction of the current, and then up out of my palm is the force. So in this case we have field lines always run from north to south, so we've got field lines going across here. We've got the current flowing from positive to negative. That way, that way. So if we just want to look at one of these sides here, it flows along here and goes in that direction there, which is sort of into the page. This is a 3D drawing. So if I was to take my hand and set it up like that, I'll draw my hand over here, my thumb is going into the page and my fingers go from north to south. The only way for that to happen, if this is my right hand, thumb into the page, fingers north to south, is if this was my fingernails. So the top of my hand is facing up and the palm of my hand, the force, is facing down. So we've got the current going this way, my field lines, the red ones are going that way, it's B, and I've got my force going down. So the direction of this force on this, we'll put it in blue, the force goes down. On this guy here is down. We can do the same thing for this other wire, and if you went through the same process, you see the field lines are going that way, so you orientate your right hand so your field lines, or your fingers are pointing to the right, but this time the current has gone around the loop and now it's coming back the other way, so your thumb's pointing out of the page. What you'd find is that then your palm would be pointing upwards and you'd have an upwards force. So if this one's going down and the other one's going up, it rotates in the direction B. So here we have direction B. Alright, what's the next question say? The current drawn from the battery is 2 amps. Calculate the magnitude of the force inside kJ when the coil is in the position shown. So this one here we have our formula, force equals nBIL. Okay, where N is the number of loops, B is the field, I is the current, and L equals the length. So let's go and find all these things in our question. We've got, highlight them in red, we've got the current here, we've got, I'm looking up to the top again, that's the 50 turns is n, 50 loops, and we're looking at the side kj, so KL and JM are 3, and KJ and LM are 6, so that's us there. This has to be in meters, so 6 centimeters in meters. This is 0.06 meters, and the magnetic field strength here, B. So let's go down. We've got it equals 50 times 0.05 by 0.06, and oh no, I put that in the wrong order, by 2 amps by the length of 0.06. And that, when I do it on my calculator, equals 0.3 newtons. Now it's asked for the magnitude. Magnitude just means size, so it's just the number we're after, not a direction. Although we had worked out the direction before. So 0.3 newtons. Done.